Hello and welcome to this infrastructure domain session as part of the buildingSMART International Summit in Singapore 2025. Thank you for joining us today. My name is John Proctor and I will be your moderator. Details of today's session are on the screen. We will have an introduction from ID Steering Committee Chair Tina Perchula, and then we will hear from Lee Gregory on why has IFC been so hard for civil infrastructure, and Jiri Bunez on ontology and interconnected data dictionary as a keystone of IDS creation. So two quite different subjects, but I'm sure they'll both be interesting and fascinating. The session is scheduled to last for 90 minutes, including time for questions, which we'll take after Lee's session and then after Jiri's session. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to Tina, I'd like to remind you that this is a hybrid session. For online attendees, your microphones will remain muted for the duration. If you wish to make a comment or ask a question, please use the chat box and I will prompt you to do so. For attendees here in the room, please keep background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and we will use the roving microphones. I'd also like to bring to your attention the information that is on the screen in a moment. buildingSMART is committed to keeping the creation of standards neutral and ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. Standards that are developed should not favour any particular provider, but are open, non-binding and accessible to all. Please take note of our antitrust of conduct. With that, I'd like to pass to Tina.
Thank you, John. So welcome all to the Infradomain first session in the Singapore Summit. My name is Tina Perttula and I'm chairing this session today. And we have two good presentations, and it was the first time in the summit that there was the call for papers, and these were what we picked as a Infradomain steering committee to be presented here today. So we have a two good presentation about the challenges in the infra field and also the good way of creation with the IDS. So with further introduction, please come Lee, stage is yours.
Unfortunately, we don't have a roving mic, so I have to use the mic here and an implement there. I'm a male, so I probably won't get the coordination going too well. So bear with me. I need these glasses because I'm getting old, so I need something to see for a distance. Right, see if this works. My name's Lee Gregory. I've been involved with IFC for quite a while. I'm a director of buildingSMART Australasia, founding member of the Open BIM Alliance. I've been going to most of these buildingSMART since 2015, and that was the one in Singapore. I also was part of the author of IFC model set up information delivery manual, which was about 2017 or 18. I've also been on the various groups for alignment, roads, rail and tunnels. I'm a passionate believer in open standards. So if I come across that way, that's the way I am. Things I'm asked about is that, do I have any family? It's nice to know a few things about me. Yes, I have 4 children and 8 grandchildren, all under the age of 8. Do I have any other interests? Not many, but I am a volunteer in the fire brigade in New South Wales, where we look after things when fires come along. I do mainly there now training and assessing people. I don't go out to big fires anymore. Do I always do smart things? I was coming back from Singapore a number of years ago. I was walking along with my mobile phone. Of course, not looking where I was going, I tripped over and I ended up ripping off my foot and also my arm. So I was in that boot and thing for 6 months. And if you're at the IFC conference here in 2015, that's what I looked like. Everyone thought I was very lazy because my wife used to go and get all my food. It wasn't until later they saw me in a wheelchair, they realised I was not able to do it myself. People also ask me, will I retire? Because I'm pretty old. When you have 8 children, grandchildren under 8, and you're working in a home office, you want a reason to get out of there. So I will keep working. Now in the audience here, I'll try and have most things up there because I do have an Australian accent, so I know it's very hard at times. But who have we got here from the construction of buildings? Oh, right, I won't insult too many then. What about civil engineering for roads, rail, things like that? Yep, excellent. Any surveyors in the room? Good. Now, things I may mention is linear infrastructure, survey data, string lines of GIS, georeferencing, bridges, and I probably won't get around to clash detection and Love Island BIM. I also won't get around to saying I am sick and tired of people seeing our industry has not had productivity gains. We have had massive productivity gains, and we should shout it out to everybody. I don't know where all this money goes, but it's not to any of us. And you'll see by what we do, we have fantastic productivity gains. Now, with civil, buildingSMART International got involved there a bit before 2015. They came up with this infrastructure room where they had a roadmap of how they were going to build on it. They also had the various summits that IFC should be used at every stage of the project, from the very beginning right through to the very end. That really means it needs to include data from surveyors, concept and detail designers for road and rail, construction and handover. That's what they've been telling us ever since I first joined. Right. Have I got the right one up here? Yeah, that's what I'm seeing. That's okay. But so for the infrastructure, they've came up with a roadmap, and basically it had a building where the alignment was at the bottom. Anyone in infrastructure has to align it because you use chainage and offset to reference everything. You don't use a grid. So alignment 1.0 was the first thing we did, which it had a alignment with horizontal and vertical segments. And basically it was done, and we actually showed that in 2016 in Korea. So that was going backwards and forwards. That's how long ago. Next was alignment 1.1, which not only had that alignment, but also added in all the rail transitions, because you don't use the clothoid transition, you have other ones. So that was added in, and also tins for surfaces. So basically that was there for alignment 1.1, and the next year in London, we were passing data around with IFC 1.1, alignment 1.1, and you could pass all that sort of data backwards and forwards, the things you want for a linear infrastructure project. IFC 4X1 came out in 2018, and it had that alignment, and it also had the triangulation. So that was out there for everyone to use in about 2017. At the same time, there's been these rooms on working on alignment, roads, rail, bridges and tunnels. That's been going on concurrently at all these sessions. And 4X3 covered rail, road and bridges. Alignment was part of it. And tunnels, that's going to be IC 4X4, maybe. I think there's a bit of a discussion about that. What they did though, IFC 4X1 had all what we really needed. They added in a whole lot of other objects, so you didn't have to use building element proxy for everything. So there's things like pavements, things like that were added in. But I know you, if you're in the infrastructure space, we all have a name for things. So even if we use building element proxy, you just put that name in there, which you can do, and it tells you what it is. It's just, they just wanted all these things over, because some people complain, oh, we've got nothing but building element proxies, but you could still use those. And here's a job that we did in 4X3, 23 or 4 years ago, and we passed it in 12D model on the left, and we passed across to UCA's US BIM. And it went all across there quite happily. Well, surveyors, designers, constructors, it's all there for you. It's all there for you. But why on earth did you feel that you're still left wandering around in the desert, that no one loves you? And basically, these IFC priesthood, they seem to have a special view of the world. And they do. They think the friggin' world is flat. End of story. That is how they look at the world. And they take that flat thinking and use it for infrastructure. Another thing you see a lot of examples are bridges. They trot these bridges out as being a fantastic example of infrastructure. Yep, they're valuable, but they're all designed in flatland. You talk to your people about what they do with a bridge, and it's usually designed in flatland. So it's not an example of what we're interested in, which is long in infrastructure, road and rail projects. So throw away any bridges if they tell you that's what they're doing for infrastructure. And how did I get involved in this? Well, it was actually when two buildingSMART people came to see me, and they had a normal project. And this is when I first learned about flatland. And they had all sorts of weird problems there, like can't bring together different floor levels and stuff like that, which we never have in our area. And they came along with this project. There's a couple they had, and they had one at New South Wales Uni, where basically they'd had all the buildings modelled and they put them all into whatever they had. And when they got to the end of it, they brought in cadastral data, the boundary data, and it didn't fit. So they come to say, what is going on? Well, since you're all civil people, you'll look at that and say, there's a few things in there that building people never worry about. Basically, they've got a whole lot of sites in there, a whole lot of lots, hundreds of them. You need to know exactly where they are. Usually for a building, they've got one big boundary, end of story, go home. The other thing is you've got large distances, and that calls up georeferencing. And georeferencing has been my passion here since 2015 when I first brought it up in the infrastructure room. And it pains me to know that I'm still having to talk about it. Another problem is what we call string lines. In Australia, we call those strings. And again, the IFC priesthood never talk about string lines. This is like a polyline or something like that. Oh no, we only talk about 3D objects. You say, well, what's so hard about a string line? Again, I looked into this because I could never understand it when you give data to a company that they couldn't read it in. We had to put string lines out as little fat pipes. I've never seen a contour line that's fat. So what I discovered, there was an implementers agreement between the vendors that they'll only draw things that are in 3D. So I looked further into it about, well, yeah, what's going on here? Can we really do anything? Or is that the way the world is with IFC? And it turns out there's a thing called IFC annotation. And it was in at least it was in earlier than 2x3, but it was in 2x3. It's got 2D and 3D points, 2D and 3D polylines, 2D and 3D polygons. So this stuff has been in there for at least 25 years because it was in even IFC 2. So they were there, and you can see how much building people thought about them. They called it annotation. That's all. It tells you, but they're there. They're there and they've been in the standard. And again, we've got a string line here, which we passed across to ACA, US BIM, and it comes across quite happily. So that does exist. The big tragedy of this buildingSMART looking at things is first is GIS. What does GIS have? Basically, it's primitive. It has points, polygons, and polylines with attributes. And an attribute is just a property set. That's all it has. Lately, they've been able to take in what we call a tri-mesh. That's only new. So that's all available as IFC annotation. So you could have been putting that data out and they should have been able to consume it from 2005. The next tragedy is machine control. Machine control, what does it want? Alignments, tins, points, lines, and polygons. They don't want this crappy 3D looking thing. They want to know a point where that bloody thing has to be dug. They want to know the edge of bitumen and stuff. Again, even alignments came in 2016, so that's all what they wanted. It's all been in there from at least 2016. So I'll just go a bit of a typical project, just to give you an idea. And since we don't have many architects and others, you'll know all about it. So this is a simple road. It was done in Sydney, 40 kilometres of dual carriageway. And always, these things aren't out in the middle of nowhere. They might be there, but they've still got to tie into local roads. So there's 20 kilometres of local road. And these days, they have to throw in 40 kilometres of shared bicycle ways and things like that. So you've got about 100 kilometres of design going on this thing. There was about 1 million square metres of paving and things, and about what's it say there? $8 million of earthworks. There was 146 or so bridges. So there's lots of stuff in there. They got 8,000 drawings. What did they do with those 8,000 drawings? Threw them in the bin. Useless. What they did, because the people who are doing design, we've had a way of getting 3D data around in Australia since the 80s. They went to the designers and got their string lines and their points and things. And from that, they were able to construct all the layers and everything for all the pavements and everything else. So they had a full 3D model to construct from. The drawings, waste of time. Here's the difference. Here's one of the sites where they're building this. And the buildings people, it's usually a fairly small site with not much going on. Out there, you've got massive machinery. We restrict who goes on that site. You don't have all these bods wandering around, they'll get killed. Massive areas. So that's one difference that's there. We've got to know where we are at all times, because you've got a 40-kilometre project, but you start at different places. So you've got to make sure they meet up. So it's very important to have the one coordinate system. And I tell you, when tunnels don't meet up, people really are upset. On the roads, it's not too bad. You can look at, oh, I'm not quite there, and you can adjust a bit, but not in a tunnel. So this is the sort of site we've got where there's nothing on there to tell you where you are, because they're bulldozed all down. They use segments of bridges. These are all different. Every one, they built special machines to control them, and the surveyors made sure they were correct. They had to build their own substation there for all the power they needed. These are massive projects. Here they put those bridges. This is one of the bridges things they were doing. And when it came to the paving, they're using the machine control for the paving. And that's the sort of thing you've got to control. Now, basically, when you do this stuff, the finished surface has to be plus or minus 10 millimetres. And they go around, you have to survey it everywhere and prove it. So the 40 kilometres, you can only be out in height by plus or minus 10 millimetres, which you can't get someone to swing your frigging door in a building to that accuracy. The construction of all the bridges, all done without survey pegs. All the control for everything was from a digital model, including all the bridges, and set out for all the bridges. They saved $1 million in wooden survey pegs. And this thing was done in 2005. So, civil people, they know about 3D. They know about machine control. They've known about it. Since I've been in industry in 1980, we only design in 3D. The buildingSMART people who work with buildings, they mainly did 2D floor levels. We can't do that. We've got to worry about full 3D to design the thing, and we always have. So basically, you would have thought, with that background, it would have been simple for IFC to include all of us, because we know all about this stuff and have for years. So, the first problem we had was cadasters and string lines, which I've mentioned, but the big one, though, is georeferencing. This has been why this thing has never worked, because they will not listen to us people about georeferencing. So basically, you have to have usually map coordinates, which are usually easting, northings, and a height on a project. One coordinate system for the whole project. Now, in case no one knows, that local engineering coordinates, that's usually what a buildings work on. They put a 0, 0, 0 somewhere, and you measure things from that. So it's local engineering coordinates. So usually actually more or less work in a tangent plane. They even say something like the z-axis is perpendicular to the other two axes. No problem if you're working. Even Einstein, my doctorate's in space-time relativity, Einstein said that locally everything's flat. Locally, special relativity works. If you're going much larger, you need general relativity. So as long as you keep in the small, there's no problem to be flatland. But just look at this. You've got a curved earth. You set up something on a tripod that's vertical, you shoot with a laser. It goes straight as a die. And if you look at that, once it gets out a bit, your heights are all wrong because it's curved on you. So you're going to be wrong if you don't allow for curvature for the earth. Luckily, when you're losing those laser things in the building, the distance is not very far, so it's not going to be too bad. How do we use georeferencing? We have to have a model of the Earth. What we use is ellipsoid, ellipse, which we spin around on the north-south axis. That gives us our model of the Earth. We then point the axis up to the North Star, because that doesn't move, so that fixes it for us. We use one in Australia, which most of the world is using, GRS 80, and it's got a mass centre of the Earth, which was not used for many beforehand. They fiddled it to fit better their area, but we use the mass centre of the Earth because the satellites revolve around the mass centre of the Earth, and most people now want to use satellites. So everyone is now using this model. So if you're using GNSS, or if you're American, GPS, then mass centre of the Earth is what you need. And it's squashed a little bit, about 22 kilometres of the pole. But for surveyors, that will make a difference. Rightio, so we've got that model of the Earth, and we don't need some other coordinate system. For that, we all use longitude and latitude. Longitude, no trouble, great circles measured east and west of Greenwich. Greenwich is the 0. Halfway between the north and south pole is your equator, and latitude is north and south of the equator. Pretty straightforward, except of course, one time Greenwich wasn't it, they used to go through Paris. So you have to know where your 0 is to play around with it. So, and those things are called your horizontal datum. So you have to know what your ellipsoid is and where your latitude and longitude measured from, and that's part of your horizontal datum, which is all very good. In Australia, ours is GDA 2020. One little problem, I'll jump over here a bit since it's just saying what ours, it is critical to know that thing. And the reason it's critical is that even in Australia, we changed models of the Earth. Coming up to 2000, we had a different model of the Earth. And when we changed it, the longitude and the latitude of every point in Australia changed. If you use the wrong one, you're out 300 metres. So you really had to know what that was. We changed it again in 2020, where the difference there was about 1.8 metres. Now, why on earth does it keep changing on us? Because of continental drift. Maybe if you're in London, you're lucky, but in Australia, we're moving towards the equator and away from London about the same rate as your fingernail grows. And over 20 years, that became 1.8 metres. And these days, if you're driving down a self-driving car, you do not want to be 1.8 metres on the wrong side of the road. Well, most houses in Australia are built up to 1 metre of the neighbour. So if you're 1.8 metres out, you'll be building on your neighbour's property. And that is not a good thing. So basically, for that, we not only have to know what model of the Earth, but we also have to know when your data was picked up. And that's called an epoch. Remember that word epoch. For Australia, 2020, it's where things were in the 1st of January 2020. So when a surveyor goes out there and picks up data, he'll pick up what it is today, if he's using satellites. He then has to adjust it to where it was on the 1st of January 2020. So it's not quite straightforward what surveyors have to do, but that's all the information you need to, if you're going to use a horizontal datum. Right, so all those things are needed, otherwise you'll basically won't know where you're going. So I noticed they talked about in, I think, IFC 4, they said, it's georeferenced. You've got a longitude and latitude in there. Crap. You need to know what the model of the Earth is, what longitude and latitude you're using, and what's the epoch. Otherwise, you could be out 300-400 metres at least. Sorry, I'm having trouble reading what I've even got there. Yeah, it's saying the same thing. But using longitude and latitude is very difficult. So we use what we call map coordinates. And what that is, you take some sort of object that you can roll out on the flat paper, and you map by going through the centre of the Earth, through your point, onto that paper to give you coordinates. That's called map coordinates. And they're usually called eastings and northings. And you use all sorts of different things for it, depending on what your data is. The conical one's used for lambda, I think, and if it's east-west, that's the sort of one you'll use. If it's north-south, you usually use the transverse Mercator. So basically, there's all these different map projections you can come up with. And basically, a common one we all use is what's the transverse Mercator, which is called Universal Transverse Mercator, or UTM. What they did is it's a cylinder on its side, And they work in 6-degree zones. So they've got a central meridian, which goes around the Earth, and you go 3 degrees each side. And basically, you've got that, and it's only about 600 or 700 kilometres maximum. But as you go up to the equator, it's smaller. To the poles, it's smaller. And once you actually have those, there's a zone, 60 of them going around the world. The Americans, I think, had this one after the war, I think. This is where it came from. But most of us use that. Certainly we use it in Australia. And we go from 50 to about across there. There's a number of zones in there. And so, because we're a little bit wide, we're about 3,000 kilometres wide, I think. Anyway, UTMs, that's a coordinate system. When you have map coordinates, and this is what it's really about, you've got your flat bit of paper and you've got your curve, and if you've got 2 points on there, P1 and P2, you go through the centre of the Earth and through that point and onto your, wherever hits the plane, that's your map coordinate. And if you look at that diagram, if you've got P1 and P2, they'll map on this P1 dash and P2 dash. Now, the horrifying thing is that flat plane is your map coordinates. And you can see there that the distance on the plane between P1 dash and P2 dash, between P1 and P2, is different to the distance on the ellipsoid. That's the horrifying problem with georeferencing. It's even worse than that, and this came up in a talk earlier today. But on that thing that goes through the centre of the Earth, nothing's on the ellipsoid. You keep going up to a certain ellipsoid height. If you go up, say, to 100 metres on each of those, and the ellipsoid height, well, that's going to be even further apart to the other. But they all have the same northing and easting. So it's not just the northing and easting, but height is critical as well. Right, so they call it a scale factor when you look at that ratio. And people do quote some scale factors, but I'll tell you why most of them are wrong. So basically, in AMG is MGA what we have, it's a UTM system. Right, oh heavens, my eyes are getting worse. With that scale factor, 0.9996, it's out about 40 millimetres, 400 millimetres per kilometre. You wouldn't think it's very much, but if you're working in tens of kilometres, you're out by metres. So that has to be remembered. Now, I did not put the hard stuff in there. The hard stuff is it does belong on height. So you also have to take height into consideration. And then you don't have actually a scale factor. It's a, oh, Jesus. It's a combined scale factor. So you have to combine the thing to get to go from one to the other.
Gone too far back.
Yeah, I'm coming forward, aren't I?
What slide are we on, do you know?
No, I'm more so. Oh, look at that. Quick reviews just so I can test you out. Right. So you do have to worry about heights, but it is worse than that. Where I spoke about there was ellipsoid height. No one uses ellipsoid heights. We use orthometric heights, i.e. the way water flows. If you lose ellipsoid heights, water has to flow sometimes uphill. We use the gravity model of the Earth to give you your heights. It is not perpendicular to your ellipsoid. So again, there's another correction coming in. So when you start talking about heights, it's different again. So you have to have a special vertical datum to say what you're using there, because we don't use geoid heights. So basically, with this stuff, do not be overwhelmed. So I can tell you now, most civil designers and things like that do not understand it either. We just give them X, Y coordinates and Zs, and you just draw away. You don't know, you don't care. They don't know what local coordinates are because you work in a map projection. Everything's in a map projection. So they don't have to know about it. The only person who does know about it is surveyors. They take all this data and stop problems and they work it out in the field. I don't like putting water in new electrical equipment. I have a tendency to knock it over. So, this was not a problem. This was not a problem at all when surveyors handle it. But people like buildingSMART and that, they start talking about large projects, digital twins. You can't have a digital twin in flat Earth. You have to have it in coordinates. Talk about GIS. It wants map coordinates. So it was all very good when you didn't try to bring data together. And most of you will have seen disaster when people bring in data from different projections and things like that. Now, a person, I was in one talk many years ago, and they said, look, no, we worked on the cross-city tunnel. We just did that in flat space. I thought, oh, yeah, right, maybe. So I went and looked up the things. But if you look and read the survey brief, it tells you, you are working in a map projection. It even tells you what the model of the Earth is that you have to use. And they fitted it a bit so it works well on the London thing, but they were all working in a map projection. But most of them in the room did not know that. They even gave you, where you were along it, a correction, parts per millimetre, that you have to adjust for. So that was all there. And when you're putting out buildings, they had marks everywhere that you had to use. You can only be out by about plus or minus 5 millimetres. So it had to be very, very exact. But most people did not know. That was worked out for them by the surveyor. So the horrible truth is, in summary, if you've got map coordinates and you work out the square root distance between them, that is not the same distance as on the ground. So you get really screwed when people pass data backwards and forwards and wonder why there's a difference. Now, in timing here, I'll jump over some of this. So basically, you've got to be careful and know what you're doing. The people, why would they know about this? Well, even the main roads for the last 100 years or so have had in their book that if you've got a bridge, which is usually done in flat land, and you've somehow moved across to your map coordinates, depending on the scale factor, it could be short or longer. And you've got to worry about that, and it affects your earthworks you're going to worry about. So it's not as though this is hidden away, it's in their survey manual. So be very, very careful. If someone doesn't know about this, if your BIM manager does not know about this problem, then they've come from the buildings world, the vertical buildings world. Tell them to go and learn about georeferencing. So it's critical, absolutely critical for your georeferencing, because all our projects, well, I'll ask the audience, are your projects in map coordinates? Who's not in map coordinates? Do you get trouble when your buildings people give you screwy data? I bet you do. So basically, you need to know your horizontal datum, which includes the epoch, and your vertical datum, the map projection, and your zone number. You need all those things to uniquely give it. And so basically, that has to be provided for a project for be able to nail it down. Now, you may wonder why these map coordinates are used and what the relationship to longitude and latitude. I didn't say, but you can map uniquely between them. So if you know the map projection coordinates and all that information, you can get back to a unique longitude and latitude on the world. So they're equivalent. They're equivalent. You've got all that information. In IFC 4X4, I think it was, 4 in 4, there's a thing called IFC projected CRS. And basically it was there, and it actually had the horizontal datum, the vertical datum, a map projection, and zone number. So if there's an IFC projected CRS, it should mean in your project that when it's read in, everything is in map coordinates. That's been around for a while. There's another little thing they had to put in for 4X3, because you couldn't have just projected CRS, you had to have one of these other objects. They made one called IFC rigid operation. And basically this has a translation in X, Y, and Z. And so how that was actually used is that what we use even in Australia at times, and we do this for bridge people, you take your map coordinates and you chop off the whole lot of the leading digits so it's much smaller. And you give them to them and they work on that thinking it's flat Earth. And what you need, so you're going to translate your data. So if you have got data that really has been truncated properly in that, you need a delta X, Y, and potentially Z to bring in the proper map coordinates. So basically, those things are allowed for, and what you do, you've got, using those two things, you've got two cases. You've got, if your coordinates are in map coordinates, all you need in there is an IFC project CRS, and you also have an IFC rigid operation, but it's just a zero translation in X and Y. If you look up what you have to do for main roads in Queensland, New South Wales, it says your project has to be in map coordinates, MGA 2020. So your data should have those two things in it, and everything should be in map coordinates, so when it's read in. And if you're for a surveyor, woe betide if you give it to a buildings person, because they'll make some local thing and they'll subtract things and whatever. You want your data to be absolute. So every coordinate is in that file, so you can look through and see that they are correct and haven't been screwed up. If you've got translated, truncated coordinates, in that case, again, you still have those same two things, the IC projector CRS, but you also have the translation. Right, so when we pass that data across to UCA, it had the information in it, and they actually were able to read it and see what the map projection was. So it's all there for 4x3. There was a test case. This was from 2021. This was in for the implementers thing. We got a railway from the Italian Railway. In fact, I think Evandro came along with this one, which is 33 kilometres long. And we had to pass that between the packages. And I hope that this is one of the test examples if you're saying you can support georeferencing and linear infrastructure. Because we read it in from Land XML, because it was in map coordinates. We had to write it out as an IFC 4x3 file and then read it back in again in different packages. And over that 33 kilometres, you had to be millimetre accurate. So that end coordinate had to be exactly there to the millimetre. So if you can't do that in your package, do not use it for civil engineering. So again, we passed that across to US BIM back in that thing, and we're able to read and write it around quite happily. The final thing I'm going to mention is small sites. I'm not totally against buildings people and bridge people. When you're working on a small site, it's good to just use ordinary rulers and things. To have to multiply them by 0.9993 and work out distances is a little bit nasty, but they're in a small site, so there's no problem. They can just use normal things. They don't have to worry that vertical is not quite vertical. It's close enough. They usually use your plumb bob anyway, which is going to the gravity. That's giving you where the gravity is. They're not using a ellipsoid distance. So how do we cope with that case? Well, surveyors and people have to do that for a long time, and it's actually quite easy. If you're on your site, you just need at least two, but you should have 4 or 5. Oh man, as I said, I'm a male. I can't handle two things at once. Tap dance. Right, small site. You get those points where you get them in the local engineering coordinates, but you also get them in map coordinates. Now, everyone, even a building, has a surveyor come out to work out the boundary. You're a bit stupid if you don't. So you can ask them to give you a whole lot of those points in the 2 coordinate system if you pick your 0, 0. So you can easily get them. And from what that you can work out a translation in X and Y, a rotation in the XY plane, and also a scale factor that you apply to the X and the Y. That will give you a mapping between a local engineering coordinate and usually to a map projection. Right, every surveyor knows that, and it's usually called a 2D helmet transformation. So if you've got that, it can be used to go between the two systems. But it only works for a small site. If you go over 1 kilometre or so, you're screwed, because those things will change. As long as it's in the small, everything's right. Also, you also have to worry about heights. You can't have too big a change in height, because that also can throw you out. But luckily for most things, you don't have that big change. Most people don't realise that with the Golden Gate Bridge in San Francisco, the distance between the towers at the bottom is different than the distance between the top, because they both go up vertical. Right. So there's a thing in there called map conversion scale. Basically, it's got 2D translation, and XYZ and the Z translation as well, rotation in the XY plane. It's got a scale to be applied to X, to Y, and to Z. For us, for a 2D helmet, those two should still be the same. And that's our 2D helmet. So if in georeferencing, if you've got someone coming from a small site, they should have in there the projected CRS and an IFC map conversion scale rather than region operation. If they've got those parameters right, When the data's read in, it'll come into map coordinates, as long as it's a small scale, a small site. And that's the big horror. When you've got a long railway and things like that, there's a different IFC map conversion scale for every site. IFC does only really handle one. So you really need them in separate files. I was told that they could handle it, but there's another thing that you can only have one 3D coordinate transformation thing. If we take away that rule, you can put it all in one file. So basically, IFC 4x3 can handle georeferencing, large coordinates over large distances, points, polygons and polylines, 3D string lines, alignments, tins, everything you need. So look, this is my coordinates in Singapore. 8, 9 and 10 digits. If you're working, you've got to have another 3 decimal places at least. That's needs 14 places. That's called double precision. If your package has to have a local coordinate, it's probably not double precision. Do not use it. So if you use Celebri or I think Revit, you'll find that if you give them something wild, it starts going wonky because it's not double precision. So if someone wants to use a local engineering coordinates to you, say no. These are my coordinates, not friggin' 0, 0. Those coordinates for Singapore, someone will know where that is in 100 years' time. They'll never know where your 0, 0 was. So basically, IFC can be civil, but it's up to you to demand string lines and don't let them cut off your friggin' digits. Thank you.
Thank you, Lee. Thanks very much, Lee. That was very, very interesting and entertaining, I have to say. So thank you for the history and for the information and for your great presentation there. Do we have any questions in the room that anyone would like to ask Lee before we move on to Jiri's presentation?
They're all civil engineers. So
Yeah.
I was just suggesting that maybe we should go to the building room or to give the same presentation.
yeah, I know, but they won't turn up.
Oh, there's the one question.
Thank you. Basically, it's not just a question, just to say great thank you, because I'm myself professional surveyor, and your presentation was a very nice example of my school years. And even it was very great that you even mentioned also distortion from the geoid model, which I thought that was forgotten. Thank you.
And there is one more question.
Did I cover your machine control problems?
Yes, I did so. Lee, thanks a lot. Very good presentation and really addressing a most important challenge for engineers and particularly surveyors. I know certainly in the UK, we've got lots of different projections. We've got a thing called snake grid that is used to, historically, I think, stitch together A-naught drawings as a way to overcome those extended lengths from the map projection. And also actually moving the datum up or down 100 meters so that we always work in positive numbers in London is another approach. I suppose my last comment is that there is also this challenge of different transformations overlapping, where when you move, and I'm sure this is the case in Australia, where as you move between states, I certainly know New South Wales want to do it their way. Do you think that the IFC and infrastructure community working in buildingSMART has fully addressed the complications through 4.3 as we move between projections and coordinate systems and datums, yada yada?
Oh, sorry. Yes, originally there was not enough information in there because they said in the original definition you had to use the EPSG codes for things. That doesn't do everything, but they've added in the 4x3 using the what's it called, the well-known text, where in that you can specify the model of the Earth and all those things. Because often, if you have a project like that, you often make sometimes a special projection. Or going from east to west, you then might use a lambda, say. Or you'll use one where there's others that you can use which go along like that, which they use in Malaysia. So in some of those projects, but by having this extra thing in there, it doesn't just belong on the PSG code which does allow you to have more local, oh, be careful, your own projection, not one of the standard ones that are there. Does that answer it at all? Only that you have to think about what projection you should use, and you may have to use a different one than just like we use the UTM for up and down. Yep. Yeah, the heights are up and down. The geo model, it's just, and there's a lovely picture I didn't have of a potato. The other thing people forget is that the transformation when you go between projections is non-linear. So the designer will draw a straight line. That's only in that projection. If you move that into another thing, a straight line's no longer a straight line. A circle's no longer a circle. That's why you say, just use this projection. Don't muck around.
One more question, then I think that we need to move on.
Sorry. I work in the maritime sector, and we always have this problem, like literally every project I've ever worked on. So we'll have a bathymetric survey of the seabed, which will be delivered to you in WGS 84, and you'll have a land-based survey, which will be delivered in a local coordinate system from whatever country you're working in. So am I right in understanding that the IFC project CRS contains all the information you need for the transformation between two systems?
It says in there that it has not got the information to have two systems and to go between them.
Sorry, no. I mean, if I then, I want all my projects, I want to end up with an IFC model of my project, and I'm mandated to use the land-based countries coordinate system. If I include all of the information in IFC project CRS, in a few years' time, when they redo the bathymetric survey again in WGS 84, I've got the information about my land-based survey to do a transformation. Is that right?
If you've got the information there, you should be able to bring it in and move it to longitude and latitude. In any system can handle it. And then once you've got the longitude and latitude, you can go out to any other projection.
The common denominator is long on that.
So you'd bring it in that one projection, put into longitude and latitude because the information's there, and then put it out to the other projection.
So thank you, Lee, for a very inspiring presentation. And then we move on to our second topic today, which is the ontology and interconnected data dictionaries as a keystone of IDS creation. So a technical, I assume a technical aspect of this. So
yes,
thank
please.
you, Jiri.
It will be mostly technical aspect of this task. So thank you for the possibility to share our progress within implementing view of few of pillars of OpenBIM within public sector for infrastructure as well for the housing. So or maybe I will just wait for a while. Yeah, thank you. So my explanation or description of the project which we are having or which we are working on is based more on the theoretical background of the whole problem. Let's say, as was yesterday very nice presented by almost a theater play by Arthur and his colleagues, is the basics about implementing of OpenBIM principles. And when we start to prepare the project, so we faced also few challenges. The few challenges has been split into some special tasks, and now we are almost at the end of this project, so which is leading into some testing phase, and those 4 bullets just describing, let's say, the small area how it has been solved. So according our experience how to work and prepare the principles of OpenBIM for common day use was the creation of local content of local national data dictionary. Then what we discovered, what was quite necessary to do, is follow some technical standard which describe how to collect the information need, how to store them, basically how to store them, even if it's for the end users, if it's hidden. I mean, maybe even if it's hidden, it's the quite good reason to build the database system based on triplets. Then what is more useful for the users is, of course, content viewing of National Data Dictionary, and then, of course, the tool for creating project-specific data standards. What is basically in the language of OpenBIM is the way how the end users can use not only national content of the data dictionary, but even how the users can handle some information from buildingSMART data dictionary, because what OpenBIM is, it's mostly the thing about the using of interconnected data. And of course, then back to the one of OpenBIM standards, back to IDS is of course creation an IDS file for data information requirement specification, and of course for all the purpose how it's IDS design and thing. So maybe now I would like to continue a little bit into the theory. Sorry. I'll try. Now I'm even able to use it. Thank you. Yep, a little bit theory hidden behind our decision why we solve this way, why we choose this way. Sorry. Difficulties for creating of local content of National Data Dictionary, and even to prepare the correct setup for creation of IDS was, as you can see, human language. That means every one of us using some different spelling, different words with same meaning, and so on. Basically, what was discovered, and even it's surprising, but it is like it is, your knowledge database doesn't exist. Basically, every field of engineering, every field of construction industry has a lot of technical standards, a lot of local handbooks, a lot of use cases, but generally it doesn't exist any complete knowledge database which we can refer like to some standardized source of information needs, of demands for creation of IDS file. Then, of course, every profession use its own technical language or jargon, and the data are really not storing like in the readable form for machines. So something is in the text, something is in the PDF, something is in the pictures. So I guess everyone knows it. The solution seems to go strictly according technical standard. Basically, this technical standard, which we are referring to, ISO 704, it's also hidden tool, but very, very useful. It goes back into the 1970s, and that tool describe the work, how men should work with terminology, how it should be managed, and basically it's the theory also behind, which is hidden behind buildingSMART data dictionary, or basically between all knowledge dictionaries which we are using. Then it comes back what it's necessary to work with terms, definition, its sources, database based on the triplets, And then, of course, we can get a final tool how to prepare the correct mapping our needs towards IFC data model as is standardized in nowadays in ISO. Here is an example. So we cannot, of course, we cannot just live in the theory. And this example, even if the word is in our local language, it's no better because what everyone can see, the word consists from the same letters. It's absolutely the same, but spelling is the same, but the meaning is completely different. For a better understanding, of course, the meaning is referring towards IFC data model, and we can see, and I guess every language has the problem. We can see that same word, different meaning. That means different mapping towards IFC, and we can see almost also different part of the road construction as is used here. The referencing is towards the PR data dictionary, which is, let's say, which is like the main source of the information from road designers, if I can say it like that. That's description, that's problems leads to some new difficulties, because when we start to collect the data, when we start to collect the information, it's appear also a lot of duplicities. It was necessary to find out the procedure, how to sort out the information requirement from different branches of construction industry. It was necessary to clean it. I guess all of you who is involved within IFC development knows this problem, but for us it was, let's say, like the new discoveries which we have to use, which we have to refer, and which we have to fight. And then again, the solution was that most of the problems even came from the fact that the data wasn't stored like in the triplets shapes, which is mean there was the problem just to find out the right referencing to the sources and to the explanation of the terms itself. So that means we work out, we clean the data, we build up the vocabularies which were focused into the profession where you are working, and then also we put the effort into explaining and creation the definition for the terms which are used. Then just a little bit of example of the last example, how was the theory built up, so, and what does it triplet means, and it's let's say in this case it's positives and or negatives related to relation database. So within the triplets database way of storing the data, is possible not even store the information regarding terms, definitions, sources, etc., but even describe the relation. Basically, it's still the same how IFC data scheme is concepted. For us, the ID came from GIS world, because when we can just check the picture, it's the work with points, lines, polygons, and even the shapes with its attributes, which we can call within IFC data schema, like properties in GIS, its attributes. Here it can be called like here it can called like the relatives in between the words. But what is the progress within our project? Nowadays, all the theory is changed into some functional prototype, which we can say like the beta version, not only the local data dictionary, not only the connection towards the buildingSMART data dictionary, but what is more important is the tool which which is pointed here, and the tool is designed for helping the users to finally produce the IDS according its specific project needs, and to use it like the support or like the source of definition and information requirements for creation of the whole IFC file format, and then continue within the OpenBIM workflow. Why we need it is the fact that why we created. The reason was that, of course, every local application has its specific demands, not only in the regulatory process, but also in the local customs, local needs, and so on. So the little bit better description of the schema of the whole project is here. That's basically, this is the first step where we collect the data. It's basically, again, similarities. It's the different domains, collected data, collected the information requirements, information needs, and then store it within local national data dictionary, where you can see what is most important is that the local data dictionary is mapped towards IFC data model, thanks the reason to use the open and neutral way how to share and produce the data, as well the reference towards the data dictionary for getting the good and or useful explanation of different IFC entities, properties, and classes, and so on. But one of the reasons, maybe, which is also not, let's say, necessary for users from other countries outside of European Union, we have to also fulfill the requirement about the open data principles, which tells us which way to share and public data. And that's basically description not only on the legal issue, like legal level, but also it has own technical description, which gives us also the information and the requirement regarding the storing data that goes or that leads backwards to the necessity of using the triplets. What also it can be a little bit interesting, because it's hidden everywhere behind this kind of data data storage or database of the information, is the structure, where, of course, the most important as well as is in buildingSMART data dictionary, is working with unique identifier of the terms, because those unique identifiers can help you, for example, to use the data dictionary like the point, which can handle with many language variant of the same term, and it's referring to the term itself. What, of course, is necessary thanks the necessity of open standard. It's the mapping towards IFC, and then the other used places, as we can see here, is just some additional information for having the data dictionary better and more useful. Even all of this can looks, as I am still saying, like the boring theory. It's really necessary to have it then, because thanks this structured data, you can guarantee like machine readability and accessibility of the data, and of course as well the interoperability, because that's one of the necessary things, like to allow to users to use the tools which they are to use to work with, but what is necessary is to share the data. This is an example how was implemented not only technical standard regarding creating data dictionaries, but also the technical standard which is used for defining the classification system or to build up the classification framework, is that the data which we collected was also necessary to structure. And for the structuring the data itself, we use those technical standards, which helps us to keep the structure and collect the information across construction industry and avoid to create duplicities. Here you can see how the data looks and how it's also slowly prepared, not only the using of the semantic definition from buildingSMART data dictionary, but also the local definition of according Czech local needs. All of this refers to some technical and legal requirement from the side of European Union, and that's the principes of open data. Because nowadays, even it seems like some hidden topic nowadays, according this description and needs through this data-europa.eu portal. It's connected almost 1.8 million data sources, which basically means that it's 1.8 different independent data dictionaries. What we think that it's useful, thanks this initiative and this technology, is that we can help us to deliver to the users more information needs about the whole life cycle, because the data sets which are over here are not only through the construction industry, but it's also from the GIS world, from the different cadastral needs, and not even only from the point of view like the properties and landlords, but it goes also to the requirement like for the environmental assets, etc., etc. And thanks the fact that we are using this technology which is here, so that means we can access those huge amount of data set through one same technology, and at our data set in the shape of local data dictionary, we can provide to the end users a more wider set of information requirement, which can be later used for defining the IDS at the export site. Here is one of the important stuff which basically following on the presentation which was before, and that's the possible to use and make or prepare and use the database structure for sharing not only the ontology data with the terminology as a source for data dictionary, but as well together with OGC, Open Geospatial Consortium, and its add-on towards the triplets database to use it like the GeoSparkle technology, which basically helps to the user not only work with the data from the point of view information needs, but also it helps us to connect it with the GIS world, because it allows us to build up queries which are not focused not only to the items within data dictionary, but also with the geospatial information, so user can combine both. And that also brings another needs to use to write and work with. But of course, we have to also prepare a whole solution or whole workflow and work set for the end users. So we did some progress as well in the end exporting tool, as well in the tool for administrating the content itself. This was the beginning of the project, was showed last time in some short presentation in Marrakesh. Nowadays the project is much more far away. What is for a little bit more advanced user, of course, is using the queries for mining the data from the database and preparing also the input for IDS creation. And as well, you can work a little bit more with the structure. As I mentioned, structure itself, it's well known from GIS world. There is nothing extra. Here we are going to the stuff which is completely new, which is nowadays under the beta testing, and some screenshot from the tool will be shown later on. And here you can see what is important. The tool, which is under some name Combine, is the tool which help us to select the project-specific information requirement. That means that user, like the designer or whatever, can took the data from the local data dictionary. With the data, it's taken also the information towards the IFC map, towards the mapping to IFC data schema, and then the user have the base set of information for IDS creation. Of course, IDS creation for the user is let's say like user friendly. That means we tried to remove the needs of some deeper knowledge of IFC data model, because the user just choosing, let's say, like the items from the dictionary, which means like the data templates, let's say it's called, and then the properties which we need to work with. Here is some schematic picture about the function of the tool itself. So it's, as you can see, it's like the source database, which provide data through the API towards the Combine tool, like the selector explorer of the dictionary. And there in Combine tool, user can choose the project specific data. So that means choose some items in the form of data templates, and then to each data template as user will need, can add some specific property which are designed within the dictionary that can be assigned towards data templates. So within the dictionary itself, there are, as well as similar principle as buildingSMART data dictionary, there are stored the data templates like the entities, let's say, and the data templates like the entities has used some property which are defined by some local needs, and both like data templates as the entities are mapped towards the entities, as well the property are mapped towards the property set and the properties from IFC data model. So this is, I'm sorry, as I mentioned, it's in the beta version. So for now, we didn't, we still not prepared the English version. So just a little bit for description. The user, somewhere here in this graphical user interface, user can choose and prepare some kind of the construction what he wants to do. So if it's some infrastructure topics, some administrative or some housing project or whatever, etc. This project, what user can choose and can set up are based on the structuring from the technical standard as I showed before. That means in our case, it's reference designation system. It's based like CCI. And then within the project, this is an example of infrastructure project. The user can go deeper and specify if his project are focused in the road construction project or rail construction project. And then, of course, some referring to some local standards which he want to follow. And within the project itself, the users can start to build up his own project-specific standard. So that means produce the selection or choose the selection from data dictionary, like to choose different items or different terms, as I mentioned, which are equal towards the IFC entities, but it's equal to IFC entities, but of course the total number is different than in IFC data model because we had to think on the local information needs. So that's why it was being created. So user set up his project specific data standard, as we call it, and then to work in each item and connect it towards the project specific properties. And as well, the properties are chosen from the data dictionary. So that's the way how we can use how we can guarantee or like standardized source of the information. Information are mapped toward IFC data model, and then we can build up the whole open BIM procedure standards for production the IDS. And after this, it's just to press the export and user can get the IDS for his future work. So thank you for your attention. This is the description of our project in which phase is right now. So, and please, if you will have questions, so I will be glad to answer.
Thank you, Jerry. Very good.
Thank you.
Any questions for Jerry? There
Okay,
are.
one question.
Hi, thanks for your presentation. We're actually doing a pretty similar thing in Finland at the moment as a buildingSMART Finland project. And now I think that we have maybe wasted some of our time to figure this stuff out because you have already done quite a lot of work with this this stuff. And we are also at the moment we are kind of creating a proof of concept of our solution, which is also relying to the semantic data, and it's using the whole complete kind of the same tool set. We are at the moment we are not focusing to the project specific IDS specifications. We are basically focusing to the specifications which are published by the buildingSMART Finland for some specific purpose.
Yes.
But it's basically just the same thing, but we haven't extended it for the end users like you have done. But this is really kind of important that these projects are shared, like in events like this, because I think the same kind of demands come from each country. So I don't know if it's even is it worth of work to do the same thing in each country. I guess this is something which should belong to the maybe for the buildingSMART or something to make it right, to have a proper semantic data and then the proper way to make the kind of the whole thing work. We have the PSDD, we have the IDS, we have IFC, but nothing is kind of connected together because there isn't kind of any ontology or semantics around it.
Exactly. Yeah, I think I agree with you. I think the same. It will be very nice if this work can be, let's say, managed through, for example, through buildingSMART. But what it shows to us during our project time was that unfortunately the local information requirement are so specific. So that seems to us to do this work, like, let's say, locally, just within the national dimension, because even if we just try to refer that building smart data dictionary and IFC data model, it has to be enough because it's the construction industry, and from the technical point of view, all of us building just roads, rails, house, what else? But still, from the professional users games, the references and requirements that they have something special. So
Thanks.
Thank you. More questions here? Artur, of course.
Thank you. I wanted to have a follow-up question. So what would you like buildingSMART to come up with? Because yeah, IFC is already the foundation with semantics, and BSDD is the platform where you can publish your national mapping to other classifications and so on. So anything else we could do? And I don't mean just buildingSMART International, but we as the community. Anyone can answer, but I will give you the mic.
I don't know what would be the complete solution. I think the problem here is that that you already have the PSDD, but that's not kind of enough because if you like to make some sort of specification, requirement specification for let's say for Finland for some specific purpose. So let's say that it's for we have now like one ongoing project which is kind of the digital ordering information for the sewer wells, and for like that sort of information, for sure you can put all of your terms to the PSDD and make your IDS file, but then you have to work out the documentation like in a manual way anyway out from it what you are actually recording. I know it's a complicated process. We are trying to streamline it that all of kind of this kind of requirements would be kind of easy for end user. Now it's not easy. You have to use multiple tools for multiple purposes, and those tools are kind of overlapping in some points. So I don't know.
Okay, thank you. So what I heard was that software should also support it better and support users in using that, right? Yeah, I agree with this, and thank you so much.
Thank you. Any more questions from audience? No? So is there any questions online?
No, there's no questions online, Tina. I think we can bring things to a close.
thank you.
So thank you for two presenters today, and they were very good examples of some of the challenges which we all as a maybe infra domain know, but now I hope that the building domain will understand our pain as well. And thank you, Jiri, for the good presentation in the national level, and like it was said that each of the maybe the local requirements may be a bit different than maybe these international requirements, and then it's a good way to balance these two. So thank you for Jiri and Lee, and then I think it's time for the coffee break, and then we continue after coffee break here with the other interesting topic, which is the use case management service and what we have been working around the topic lately in the infra domain. So I hope to see all of you here in this room after the coffee break. Thank you.
Thanks very much. As Tina